So I will be talking about the future of vehicle manufacturing. And basically, contrary to the last couple of decades, it's an environment which evolves very fast and offers a lot of really cool opportunities. So, while we are focusing mostly on self-driving cars, electric cars, hydrogen cars, ride-hailing, I think that we overlook the exciting disruptions happening in the field of vehicle manufacturing. What influences the disruption are several factors, both technological, like AI, big data, but also social, like globalization, environmental concerns. So in my talk, I will focus about 3 areas: robofacturing and AI on the factory floor, giga versus micro factories, and lastly, vertical integration as an enabler of innovation. Hopefully, by the end of this talk, you will understand the challenges and opportunities in the field of car manufacturing. I encourage you to join the manufacturing revolution if you find those topics interesting, because as Henry Ford said, vision without execution is just hallucination. But before we jump into those topics, I would like to tell you how we actually build a car, right? If you want to build something, first you need parts. Luckily, on the factory floor, we have machines which create parts for us. So on the left-hand side, you can see a stamping machine. Stamping basically means you take a flat sheet of metal and you smash it into a useful shape, for example, doors. On the other hand, casting is a process where you pour a liquid metal into a hollow cavity, and then once the metal solidifies, you basically get out a part. So once you have those parts, the next step is body in white. This is basically the part where you join the parts to create a frame or a body of a car. This is being done exclusively right now by robots, which basically use manufacturing methods like welding, gluing, riveting to join the components together. Then the assembled car goes to paint, where it gets cleaned up from all the oil and metal chips, and then layer after layer of paint gets applied. And the final part of the whole process is final assembly. So imagine a line, like a conveyance line, divided into several stations. And in those stations, human workers install various items which turn a painted body into a drivable car. This could be upholstery, chassis, glass, electronics, motors. So that's how you build a car. So next one, it's about robofacturing and AI. So I'm going to give you a short history lesson. 1920, the assembly line, the invention of Henry Ford, was a game changer. We're able, for the first time in the history, to produce a complex product cheaply, in a serial way, and very fast. So to build one car, you need just 1.5 hours. All the work was being done exclusively by humans, and the assembly was being done by pulling the rope to move the cars. 1980s, first robots in the car factory. This is, I think, the Ford Sierra's factory in Cologne, Germany. And the present day, right now in the Ford factories, you can see many more robots, much more sophisticated, and that allows us to basically produce 1 car per second. You can see a lot of robots in the car factories, for example, in the body assembly, in the paint application. They've been there for decades, but they're only used for very simple pre-programmed tasks. So the robot does one thing over and over. Most of the people are still working in the final assembly, which is the most complex part of the whole process, because you need, quick adjustments, handling uncertainty, dexterous manipulation, and general intelligence, something which humans are much better than robots. If your robotic system has a success rate of 90%, this roughly means that a human needs to intervene every minute or so. This means, it's a full-time job for a human. So in order to have a reliable, automized system, it needs to have a success rate of 99.9%. which is extremely hard for AI nowadays to achieve, let alone to maintain. AI is not ripe enough to be used in the manufacturing industry, but I believe that soon we will see cognizant and dexterous robots which can solve same problems in the same environments like humans do. Once the AI technologies graduates from academic to commercial use, we'll see robots which are very adaptive, able to handle novel situations and edge cases. For example, Covariant is the company which does exactly that. They transplant cutting-edge ideas from academia into industry. They tackle the problem of sorting in the warehouses. So their robots don't have expensive sensors or complex hardware, but they have amazing machine learning algorithms which allows those robots to learn new tasks fast, reuse past experience, and learn from the data across the fleet of all the robots. This allows them to solve problems which were previously very difficult for standard robotic systems to deal with. So items which are glassy, shiny, deformable, wrapped in the plastic package. So it's not anymore a research project, it's a real solution proved to work in an industrial space. Last month, Alphabet, Google, has announced that their company, Intrinsic, goes out of the stealth mode. Intrinsic's mission is to basically use the novel advancements in the AI to make industrial robots more useful and flexible. While they haven't shown much, they have demonstrated that they can solve a couple of use cases, like, for example, inserting USB cables or assembling IKEA-like furniture, not in the pre-programmed way, but really by intelligently sensing and acting in the real world. Hopefully, this can be translated into fixing bus connectors in the cars or installing airbags. Finally, Boston Dynamics. You may know them as the creators of really cool music videos, but they are primarily one of the most astonishing robot companies in the world. They were finally bought by Hyundai last year, so Hyundai took full ownership. And now the question comes, why would the car manufacturer buy such a robotic company? One of the obvious reasons may be logistics. So, for example, Handle robot is an electric robot with car wheel motion system with robotic arm and the gripper, which is perfect for optimizing the logistics in the warehouses. Hyundai is also working on the walking car concept, Hyundai Elevate, and maybe Boston Dynamics can also help with that. I was talking about robots, stationary robots, but there are also mobile robots like walking cars. Here I would like to speak about the conveyor system. So for the last 100 years, the way how we moved the material in the factory was using the conveyor systems. But they are not the best. Once you install the conveyance systems, it's really hard to change it, repurpose it. This is why maybe we can use mobile robots for that. So imagine that on your factory floor, you have robots, a bit like Roomba vacuum cleaner, which whiz around the factory floor and carry the parts from one station to the other. Those robots, in the context of manufacturing, are called AGVs, autonomously guided vehicles, and are being used right now, but in a pretty dumb way. So Kiva robots in Amazon, they're pretty cool, but they're not as cool as they could be. Because right now, mobile robots can be more like autonomous vehicles, equipped with advanced sensors and also great perception systems. They could basically be much more flexible, much more intelligent, very easy to repurpose. They're also getting much cheaper, and they could be as reliable as the good old conveyance belt. OK, so next topic, Giga versus Microfactory. So whenever you want to build product at a scale, it really makes sense to have one big factory and take advantage of economies of scale, right? But big systems, just like Roman Empire, need a lot of energy to maintain themselves. So to have a big factory, you need to pay salaries to your workers, rent for the land, you need an advanced network of suppliers, also of the delivery network to send your product all around the world. And there is this idea that maybe we shall not have just like this one big system, which is hard to maintain, but instead of having one big factory, we can have several smart but high-tech manufacturing units, which we can place directly to your end customer, microfactories. So for example, I could have one microfactory in Texas producing big trucks for American market, and then one microfactory in Hungary to produce small cars perfectly suited for the cozy streets of Budapest. What are other advantages? Well, they are small, flexible, easy to repurpose. They can quickly react to the changes in demand. Second, they are much easier to design, permit, and build. Several months instead of several years to build a factory. They can be much more environment friendly. Smaller footprint means basically less emissions, less waste, less energy, less raw material. They could perhaps operate fully on the renewable energy, something which a real factory, big factory, could never do. And the same people who will manufacture the cars will also drive them. While it's being said that the job loss coming from automation globally outpaces the job creation for automation, I believe that locally, the opposite might be true. That basically, locally, automation may be job creator and not job destroyer. And finally, we have to speak about COVID. So last year, all of you remember, because of COVID, the supply chain was completely disrupted. It was impossible to get anything shipped, from electronics through steel down to food products. The car manufacturers lowered their outputs because they anticipated that there will be contraction of economy and people will not be able to buy cars. But then the supply went back on its track in like three months, and all of us, close in our homes, started buying computers, graphic cards, game consoles, TVs. The price of Bitcoin has tripled over like the first 3 months of this year. So basically, all those devices, electronics, Bitcoin miners, they need chips, semiconductors. So in this world driven by technology, the car manufacturers woke up and realized there are no chips on the market. And cars are computers on wheels nowadays, right? So GM basically lost about $2 billion because of that, and the whole industry is estimated to have suffered a loss of $60 billion. Also, the Suez Canal accident. One unfortunate evergreen ship basically have stalled the supply chains for a week, and every day costed us, the world economy, $10 billion. So where I'm getting is the fact that microfactories will have simple, local supply chain, which will be much more robust to those humongous supply chain problems which we have seen in the future. So a couple of cars which were built in such a fashion. This is the Rally Fighter from the company Local Motors. The cool thing about this car was that exterior was basically chosen by the crowd voting. So there was one of the fans who submitted the proposal, and it's a pretty cool idea that you can basically crowdsource the creation of the car, and then somebody who wins basically gets royalty from their design. Another company, a rival, they are like right now very, very let's say, famous microfactory company. They come from England, but they are building right now 2 microfactories in the USA, in North Carolina, and they will be building delivery vans for UPC next year. And the final topic, vertical integration. So Alan Kay, one of the early engineers in Apple, said people who are really serious about software should make their own hardware. And he was alluding to the concept of vertical integration, which is basically a business strategy when a company owns several levels of their production supply chain. I think that one of the reasons why Apple is so successful is because they were integrating vertically very hard. They own their design, hardware, processors, peripherals, software, iOS, macOS, App Store, as well as services like retail, Genius Bars, Apple Care. But the car industry has refused to integrate vertically for years. Instead, they used suppliers. They bought competencies. And using outsourcing competency may make you cost efficient in the short term, but in the long term, it may harm your ability to innovate. Now, let's say that you buy batteries from somebody else. You will not have to hire battery experts. You will not have to build battery factory. But if you learn how to build batteries, you'll be able to manufacture them cheaper, you will be independent, you will own the knowledge, and you'll be able to innovate faster. So basically, smart vertical integration is a powerful tool to differentiate yourself from the competitors and basically run the innovation very fast. Tesla was the first automaker which made a really big bet on vertical integration. They own so many competencies, from motors, batteries, through self-driving algorithms, and even solar panels. Tesla is a chain of startups which together in unison allow for blazing fast innovation. Also in the field of car manufacturing. So the company bought the biggest casting machine in the world to basically cast two very important parts of the car, the front underbody and rear underbody, as in one part. So usually to manufacture those parts, you need several subcomponents. You need to join them together, which is cost inefficient and takes time. And they basically cast it as one piece. They join the front underbody and rear underbody using the invention called structural battery, which has a dual purpose. On one hand, it's an energy source, like a battery. On the other hand, it's a structure which carries the forces which act on the car. So this set of innovations allows to manufacture the car, which allows for mass reduction of the car by 10%, simplification of the process by deleting almost 400 parts, and as a result, reducing the area, the footprint of the factory by 35%. Right now, other businesses understand that vertical integration makes sense. For example, Zoox, the San Francisco-based company which manufactures robotaxis for urban dense environments, they own design, manufacturing, hardware, software, sensors, and this has allowed them to pioneer the space of future mobility. Amazon has seen that, and he bought Zoox for more than $1 billion, which was the third biggest acquisition in Amazon's history. And Amazon, when it comes to money, Jeff Bezos is a baller. So basically, in the boardrooms of the most known, most established vehicle companies, the directors have understood that those disruptors like Tesla, Rivian, Lucid have arrived. Before, those dinosaurs had the innovation lane all to themselves. But right now, they understand the future is not about producing more cars more cheaply. It's about redefining the vehicle and the business. Volkswagen, for example, seems to understand that. They have announced that by the year 2030, they will open 6 battery-making gigafactories in Europe with the intention of slicing the cost of the battery by 50%. Given that Volkswagen produces every year about 1 million cars, this can be a really good move on the cost efficiency side. But what are other ways how you can drive innovation? Perhaps through partnerships. This can go well and also bad. So for example, BMW and Daimler, they joined their forces to work together on self-driving algorithms, but after 1 year, they resigned, saying it's too difficult and too costly. On the other hand, Ford and Volkswagen, I think also last year, they forged an alliance to work together on the electric vehicle platform and also self-driving cars. And I think 2 days ago, it was announced that they will deploy their test vehicles in Munich. So super excited about that. And also Jaguar and Waymo, the Google self-driving project, are working together on the new Jaguar I-Pace. While vertical integration can be a really risky and costly move, so can be partnership. Having 2 big corporations working together and having meaningful results, it's a bit like putting 2 800-pound gorillas in one cage and expecting them to collaborate in some meaningful way. Remember that the future belongs to us, so drive fast, but keep your hands on the wheel and eyes on the road. Thank you very much.
Thank you very much, Damian. That was fantastic. Really interesting. Thank you. All right. So now it's time for Q&A. Damian, I'm sure that you've seen lots of Q&As before.
Yes.
But this is not one that you've participated in for sure.
Definitely
All
not.
right. So this is a game called Turning Point. What happens is you sit down over here in the seat of doom or destiny, however you want to look at it. All right? And what's going to happen over here? Guys, if you have questions, please come down the sides over here. Look for our volunteers. They will guide you. You face your first questioner on your left over here.
Yeah. Hey, nice to meet you, Damian.
Nice to meet you. I'm Edwa. My question is, even the assembly and making a car, is that will be 100% robotic, or is that the future?
I think that there is no reason why it shouldn't be 100% robotic. So I think that, I'm really optimistic. There was a talk about, how AI is overblown, and I do agree with Eric to some extent. But I think when it comes to this narrow AI, which is basically a robot which, picks and places or just screws something, it's very difficult to do right now. It's mostly done by humans. But I believe that given enough time, we have enough brain capacity as the human race to basically figure it out. And I really believe that we're going to have the so-called dark factories, where there are no humans, it's just robots completing the step from A to Z.
Thank you very much. All right, next question, guys.
Hey, Damian. So my question for you is that we've seen things about the driving and the manufacturing in the car industry.
Yeah.
But I've been wondering, what are the other industries where the development is this fast and this innovative?
Wow, really good question. The people work on very, very general kinds of problems. So, for example, the pick and place problem, the insertion problem. So I would say that even though it's hard for me right now to tell you what are the other fields, I think that once every field helps each other, because in the end those skills can be transferred to all the other businesses.
Fantastic. Thank you. Next question.
Yeah. Hey.
I'm not sure if you mentioned that before, and I'm sorry if you did, but then can you please recap? So on a conveyor belt, from beginning to end, what's the speed of producing a car right now, and what do you think the future can be for it? How much can it improve?
Well, it's slow. I mean, it depends. In the where you have robots, you basically want to make it as fast as possible for the robot, which is fast because robots are fast, so you can just churn those cars pretty quickly. But once the cars arrive to the final assembly and the humans have to work on them, you basically slow them down so the human can catch up. If you go to, for example, like Audi factory, they have like those special ropes. So once the human realizes that I cannot make it, it's too fast, you can pull the rope and you can stop the whole production so that one guy can catch up. Which is why I don't like this conveyance system idea. I think that we can do something much less linear, like something more parallelizable. Yeah, but it's slow.
Thank you. Thank you. Next question.
Hey.
My question is more theoretical. So when we are driving, we are taking decisions, but a self-driving car is taking the decisions instead of the human beings. And where is the border? What kind of decisions are possible to take of the self-driving car, and what is the decision is not possible to take?
Well, if you think how humans, in a very simple way, we basically map from our observations to our actions. So in this case, robot can do the same. The problem is about the high-level thinking, about the emotions, figuring out the intention of the other person. So I would say it's very difficult to say. So theoretically, robots could learn this mapping, like a mathematical function. But right now we see that it's maybe much more difficult than we think, and once again, it's about creating an intelligence which is much less general than just one specified task. And this is where the problem is.
Thank you. Next question.
My question is that I like to drive. I really like to drive, but not the new cars, because they are so smart and they do different things on their own. So the future is that cars will drive themselves, even though people like to drive.
I think Elon Musk said this, people still drive horses for fun. So I guess it would be the same. If you have your Mustang from the 60s, I would much rather, spend a weekend driving a Mustang like in the coast of Italy than an autonomous car in a big city in Europe. Yeah, I would think it's not exclusive.
Thank you. Next question.
Hi, I'm Victor.
Hey, nice to meet you.
I work as a climate change educator. Do you think that in a world with rising CO2 emissions and with resource exhaustion, do you think this will put a pressure on the car industry?
I think right now we can see that even a lot of people don't agree. We are shifting to electric only. Like all the new cars are being electric. All the old manufacturers, they basically either like artificially sustain their combustion engines or they go directly into electricity. So I would think, I don't have a stance, to be honest, but a fact is that the industry as a whole does shift to the electric cars. Hydrogen is also a possibility, but I would not be so bullish about that.
My question is, you mentioned all these micro factories, and some of them are already popping up.
Yeah.
If I envision a future with these micro factories all around the globe, how do you think the supply management problem would be solved in these factories? What are the best practices right now?
One of the things which basically hinder the micro factories is the fact that the supply chains are not uniformly distributed over the world. So for example, semiconductors, the chips, they're only built in Asia because of the low labor costs. So the thing which needs to happen, and it depends on your ethical and economic significance, what we value as humans, but you would need to shift, let's say, more manufacturing from China to all around the globe, which may be difficult to do.
So I really like people's obsession with being replaced by robots. So my question is this: what keeps you from being replaced?
Yeah, I don't know. Ask my boss. Well, we'll still need people to, guide those robots, to basically supervise those factories. But if you do work which is repetitive, which is unsafe, in an environment which is hard to work, like in places which are
that awareness?
unsafe,
do we just repress it and pretend like everything's fine, or do we actually experience it and turn towards the future with some specific goal-making in
some
mind?
other inspiring and really nice work environment?
Thank you.
Ladies and gentlemen, that wraps up the Turning Point game. That was our last question. Thank you so much for participating, everyone. Damian Bogunowicz, I really appreciate you coming here.
Thank you very much, man.
Give it up for Damian Bogunowicz, everyone. Damian, thank you so much for coming.
Thank you.
Really appreciate it.
It was a pleasure.
All right, thank you.